Welcome to The Explainer. Today we're going to uncover some of the hidden science in, well, pretty much everything. From the air you're breathing to that coffee in your cup. We're talking about mixtures, and I promise, once you get what they're all about, you'll start to see the building blocks of your world in a totally new way.
And it all kicks off with a really simple question. You mix hot water and ground coffee beans to make your morning brew, right? But when you go to take a sip, there are no grounds in there. So where did they go? The answer is the perfect way to dive into the chemistry of how things combine.
So, to figure out our coffee mystery, we first have to get a handle on what a mixture actually is. And yeah, a salad is a great example, but trust me, the idea goes way, way deeper than that.
Okay, so at its heart, a mixture is just a physical blend. The key word there is physical. The ingredients are all mixed together, but they haven't chemically changed into something new. Think of it like a crowd of people in a room. They're all sharing the same space, but they're still just a bunch of individual people. And you really do find mixtures everywhere you look. In a salad or a bowl of soup, it's pretty easy to spot the different parts, right? But what's really wild is that the air we're all breathing right now is also a mixture, mostly nitrogen and oxygen gases. You can't see the individual parts, but believe me, they're there.
All right, and this is where it gets really interesting. It turns out that not all mixtures are blended in the same way. Depending on how all those components are spread out, we can split them into two main categories.
First up, let's go back to that chicken noodle soup. Think about it. In one spoonful, you might get a bunch of broth and maybe one noodle, but the next spoonful, you might get a big chunk of chicken. The point is, the composition is not the same all the way through. It's totally uneven.
So the fancy scientific name for this kind of uneven mix is a heterogeneous mixture. And a good way to remember it is that the prefix hetero means different, which is perfect, right? It reminds you that the composition is different from one part of the mixture to another. But then you've got these other mixtures, like air or, say, vinegar. If you took a tiny sample of air from one side of the room and another from the opposite corner, their composition would be exactly the same. Everything is perfectly, totally, evenly blended. And yep, you guessed it, we've got a name for that too. A homogeneous mixture. Homo means same, because the composition is the same all the way through. You might actually know this by another name too, a solution. Okay, so let's put them side by side just to make it super clear. On one hand, you have heterogeneous, not uniform with multiple phases. Think about oil and vinegar dressing, where you can literally see the separate layers. Then you have homogeneous, completely uniform, just a single phase, like salt dissolved in water. Once it's stirred, you can't see the individual salt crystals anymore.
All right, pop quiz time. Picture it, you're at the beach. You've got the ocean water and you've got the sand. One is homogeneous and one is heterogeneous. So, which one is which? Take a second.
Did you get it? If you said the ocean water is the homogeneous mixture, you are absolutely right. The salt and other minerals are evenly dissolved, and that means the sand is heterogeneous, because if you look closely, you can see all those different little bits of rock and shell. Every handful is just a little bit different.
So, we know how to classify mixtures now, but how do we unmix them? Well, to figure that out, we have to circle all the way back to our original coffee question. The answer is all about the science of separation.
Here's the secret sauce to the whole thing. To separate a mixture, all you have to do is find a difference in the physical properties of its parts. I mean, this could be anything. A difference in size, in boiling point, you name it.
Okay, so our first separation method is called filtration. And pay really close attention here. It's a process that separates a solid from a liquid in a heterogeneous mixture. See how it's all starting to connect? And the process itself is actually incredibly simple. You just pour your mixture through some kind of filter that has teeny tiny holes in it. The liquid can pass right through those holes, no problem, but the solid particles, they're too big. They get trapped.
And there it is, our aha moment. Brewing coffee creates a heterogeneous mixture, right? You've got solid grounds floating in liquid water. That paper filter is just a simple tool for filtration. It traps the big coffee grounds while letting all that delicious liquid pass right on through into your cup.
But wait, what about separating a homogeneous mixture? A solution where everything's dissolved and you can't see the parts? Well, for that, scientists often turn to a process called distillation. And this one is all about using differences in boiling points.
So just imagine you have salt water. We all know water boils at 100 degrees Celsius, but the salt's boiling point is way, way higher. So what you can do is boil the water, which turns it into steam. That steam travels down a tube where it gets cooled down and turns back into pure liquid water, leaving all the salt behind in the first container. Pretty clever, right?
So just to recap the separation science really quickly. Filtration works because of differences in particle size. The big solids can't get through the filter. And distillation works because of differences in boiling point. One substance turns into a gas while the other one gets left behind.
So when you start to understand these concepts, you see that nearly everything we deal with every single day is some kind of mixture. And we use these ideas of separation all the time, a lot of times without even realizing it.
Okay, so if you walk away with just two big ideas today, let them be these. First, every single mixture is either heterogeneous, unevenly mixed like a salad, or homogeneous, perfectly uniform like salt water. And second, we can get really clever and separate these mixtures just by finding a physical property that they don't share.
So next time you pour a drink or sweeten your tea or even just take a breath of air, just pause for a second. Think about the science that you just learned. What kind of mixture are you looking at? And how would you go about separating it? The world is just full of these little hidden puzzles, and now you know how to start solving them.